have an interesting topic for today. I'm with my buddy Duncan.
What's up?
Yo. What's that?
How's it going?
Let's see. So Duncan is he does what would you call it?
I'm just kind of an amateur programmer, but I guess my message is that, programming doesn't have to be super intimidating. It can be fun, and it doesn't have to be like a super extensive project. Like, you could have a short, simple example and maybe get some cool results with it.
Yeah, totally. And it's interesting because programming is something I've always wanted to get into, and I'm very visual, and like the whole like coding aspect of things, like I just haven't really ever gotten to like take that dive into it. Just I've always been into like graphic design and motion graphics and stuff like that, but like video editing, but like that's very visual type of coding, I guess I would call it coding in its own sense. But but with the concept of being able to program like I guess I would say a process that is functional and does things as opposed to more of like just a visual illustration, has always it's been like my limiting factor. I'm like, if I could do that, I could do so many cool things. So anyways, so Duncan, you created, what was that, the program that you created?
I think I was just had kind of done some programming stuff in high school, and then I think I was just bored in college in like a psychology class or something, and
Perfect.
I wrote this program. But it's cool that you brought up the visual aspect, because processing is a language, and basically it's a platform that's for visual arts and for just getting a project done and out really quickly.
Gotcha.
Just sketching ideas, but it is,
that's cool.
It is extensible and powerful and all that.
That's really cool. Yeah, that's really awesome. And so you're so we're gonna be showing the program that he created, which is what do you call it again? Like just a visual processor, would you say, or
it's just like a visualizer for creating art.
Yeah,
I would
gotcha.
say.
Okay, like computer generated art, essentially, right? Mm-hmm. You say. So yeah, we're gonna basically go through how you can what program you need to do that, how to download it, install it, get it running, and then how to make it work and how to program that. It's kind of like the basic steps to programming that. Am I explaining that correctly? Would you say?
Yeah, I'd say just like a basic introduction to coding, but in the context of a visual project.
Visual project. Cool. So if you're an artist, or you do programming and you want to get into this type of thing, or you're just interested in seeing a different type of way that you can create, this is, I think, is a really cool start. So we'll start off by going. Duncan's gonna actually guide me through the process, because I've never done it before, and I'm really interested to do it. So we're just gonna hop on the computer that we're already on and streaming from, and we're gonna be running the program from there. So what's the first thing you think we should start with?
So I guess maybe go ahead and pull up our
good old program,
our processing environment.
Processing environment. Okay, cool. So if for the people who are at home, you go to what is the website?
If you don't have it already installed, it's processing.org, and you can download it from there. It's free. It's open source, so you don't have to pay anything.
This is the website right here.
Sure, they would appreciate a donation, but you don't have to. And then just get that installed.
So you just click download processing, and then whatever donation you want, and then you download it.
At least $1,000.
Yeah, give it at least $1,000, and then move from there. But seriously, I think I do want to. If I end up using this, I definitely will donate, because I appreciate open source software, and they need to be funded. But anyway, so cool. So we got this. We can download it, and we did do that. So let me move over to the actual system here. So we got the application. Okay, cool. Okay, so here's the actual application. Look how pretty that is. And so we got it on our screen. Do we want to start with yours to show them what yours looks like?
Sure, yeah. We'll just kind of can kind of show them what the basic structure looks like.
Okay, so this is Duncan's
So-
program called Hex Shape. And go ahead. Yeah, you can go ahead and explain that one.
Okay, so basically this is a program that is really simple. I mean, I don't know if it looks simple or not. Probably depends on how much programming you've done. But, so basically, and I'll kind of go through this later, but there's different functions that are going to do different things, basically.
Okay.
And so we're going to walk you through that step by step and hopefully clear up, any points of confusion.
Okay, cool. And like, should I just run this just so people can see? Okay, cool. So we're gonna run the program right now, just so you guys can have an idea like what this looks like as like a finished version. So let me get connected to the actual program here. If you guys give me a moment. But let's see. We got let's see. Oh, there we go. Okay, so here we have the actual program. And so how do we run this?
Okay, so basically this is just going to create a simple shape that rotates around the origin, and so there we go. So and so this was kind of just a cool thing, and so you can see that the way that the line is, there's a certain separation there that kind of creates these cool patterns and effects, and of course you can modify like the colors that are happening and like the speed that the color changes and all that.
Interesting.
And then we can also like change our shape here, so we've got kind of a line here, and then see we're rotating that around.
Oh, interesting.
And then
so you can kind of change your.
It's kind of like a paint. It's kind of like a paintbrush or a.
Yeah. Wow, that's so cool. I love that. That's so pretty.
Yeah, you
Very
can get
sweet.
some interesting stuff out of it for sure.
So you coded the process for these like circular motions essentially, and like the length of like the lines at which like.
Yeah, that's a good way to put it.
Interesting. So basically you're just pushing different buttons on the keyboard and they have different values assigned to them. Like what's like the one like the first button? What's which which one?
So
are you right now?
I'm controlling. So right now I'm controlling the shape, and so right now, like I can zoom out sort of, and it's got this big sort of polyhedron here, and then we're zooming in, and now it's like just this tiny little thin line but it's creating different patterns, obviously.
Yeah. Is there like
And you can
So can you like create like basically like are these like is the algorithm like a fractal pattern, or is it just like a random pattern that you created? Or like is like a fractal pattern just the repeating nature kind of a thing?
Are you talking about the
Like
colors or the?
Like, you know what I'm saying? Like with like so let's say like the Fibonacci sequence is like a fractal pattern. You know what I'm saying? Like it's like this constantly repeating pattern.
Mm-hmm.
Can you create the same sort of thing using this program? Does that make sense? Is that the right question to ask?
That's actually pretty cool. I haven't seen that before.
Yeah.
I think the most advanced math in this is just like trigonometry.
Okay.
So like sine and cosine, and we'll go over that in a second. But
so you can probably create.
Yeah, I don't know. I haven't really
pattern.
thought about the fractal aspect of it or not.
I'm curious what like the definition of a fractal is. I'm assuming it's a repeating pattern that like looks the same from a large scale to a small scale.
It's a shape that contains itself that's also self-repeating.
Gotcha.
So
Right.
so for instance, like but it also contains, so like the coastline of England is a famous example of a fractal, because if you look at the coastline of England from a map and you measure it, then you're gonna get a different measurement depending on how closely you zoom in to the coastline.
Gotcha.
Your measurement's gonna change. So
interesting. Yeah.
Yeah.
Okay. Cool. Well, do you want to go into like how you actually start building something like this?
Sure.
Cool.
Yeah, absolutely.
Awesome. So basically, one more question I have is like, oh, it's going on its own. That's kind of cool. Can you it can do that as well? Clearly.
Yeah. I'm just kind of setting the.
Okay, so basically,
here.
Okay, cool. So it's really like hands-off kind of a thing. You kind of like let it. You really just push a button and let it go and repeat on it. So you're not like holding it down.
Yeah. I mean, everybody sort of has their own technique, I guess.
Okay.
Like.
Wow, that's so cool. Wow.
Like you can really.
That's so trippy.
Like I've been
That's
like really
amazing.
impressed by like some stuff that I've seen people see. So like now
this is super cool.
It's like rotating so fast that we're sort of getting that sort of fan effect, like where
wow, this is phenomenal.
Like
I really love
I forget
this.
what that's it's like you're seeing the same thing, but it's like your eyes it's faster than your eyes are perceiving.
Right.
So
that's really sweet. I love that.
So it's just kind of a cool. Yeah, I actually haven't messed with this in a while, but you can get some cool stuff out of this.
Yeah.
And I'm trying to port this over to virtual reality. That's been my project the last couple days. So,
dude, like
as you can see, with the proper chemical agents, you could spend some time.
Oh my god, this is so good.
Creating some cool stuff.
Wow, it's so cool. Awesome. So
yeah.
I'm like totally inspired to like figure out how, like learn how this is done. So
yeah.
Oh my god.
Let's get to it.
All these pans are
yeah, like kind of one of the coolest parts to me is like you see those little like those lines that are like between the lines, like those you see those sort of like how would you just like patterns in the patterns?
Yeah, like they're like what's the word? They're cross dynamics. They're not like cross. They're like
it's called. I think it has a name for it.
There is a name. It's called like what's the word? Interference patterns. Is that it?
Yeah. It's like an interference pattern.
Yeah, because that's the same thing with holograms have interference patterns, and like that's what creates the hologram.
Okay.
Or, I mean, like that's part of the creation of the hologram is through the light reflecting off each other and like.
I've heard it called the Mare effect.
The Mare effect.
So you can,
interesting.
if you're into that sort of thing, look up the Mare. Like you can see it on like laundry baskets and stuff like that.
Okay.
Anytime you've got like two mesh patterns. But anyways, let's get to it.
Cool. Awesome. I'm just like so mesmerized by this. Okay, we'll come back. Come back to reality here. Cool. Okay, cool. So we switch sides and we're good. This is fine. You get in the camera so people can see your pretty face.
Yeah.
Okay, cool. So actually, it might be easier if I'm on this side because like the keyboard's here. Okay, cool. So first thing we want to do, let's go back to the program. So here's Duncans. There's a new one. Okay, here's the new program. Cool. Let me pull this one up on our end. All right, cool. So what's the first thing?
Okay, so basically with programming, each sort of like everything is compartmentalized and everything is logical. So the way I like to think of it is that you're building your own world, and everything in the world is going to follow this set of instructions that you give to it.
You're building your own world, and everything's going to follow a set of instructions that you're providing to the program. That's
exactly.
what you said. Okay, cool.
So you just have to be able to specify what you want in a language that the computer can understand.
Gotcha.
So I'm just going to leave both of these windows on top here so that we can kind of see back and forth. But if they can look at this one so they can see what you're doing.
Okay, cool.
Is that
actually possible? I'm going to put both on here so that I think we can do that. Let's see. So basically, here's Duncan's setup, then here's mine. And is there any important? Here, I'm gonna see if I can make this a little smaller. Probably.
Yeah, I mean, like they don't necessarily have to see the one that I already wrote because we're gonna walk them through that.
Okay, cool.
But
so
we
got this.
Just for my reference.
That works. Okay, cool. So we got this. I'm gonna bring this down a little further. Okay, cool. Awesome. So what's the? Okay, cool. What's next?
Okay, so to create the world, the first thing you're gonna do is run the setup.
Run the setup. Okay.
And so you'll type in void setup.
Void setup, just like on the first line here.
Mm-hmm.
Void. Ooh, this is fun. Void setup.
Mm-hmm.
Error.
And then you're gonna need a set of parentheses.
Just regular like that. Or a semicolon.
Like the.
Parentheses.
Open parentheses, close parentheses.
Oh, my bad. Okay.
And
gotcha.
then you're gonna need a bracket, or I'm sorry, curly braces.
Is that a curly brace?
Yeah, and then another curly brace.
Close. Okay, cool.
Okay, and so in programming, I guess these are functions, and so what would go inside the parentheses is going to be your arguments, and then what's inside the braces is going to be what you're running in the function. So
can you just like define what an argument is for those that don't know what that means?
Yeah, an argument is going to be something that modifies a parameter. That's kind of vague right now, but maybe we'll just keep going and like I'll kind of explain more.
So for instance, like we have a parameter of like the screen
say,
within the screen. All right, go ahead.
I think it'll make more sense like in a different context. So let's just keep going and I'll kind of get back to it. But
awesome.
Okay, so then put some space in between your braces there, so you can type stuff in.
Oh, okay. I get what you're saying. Like that.
Put
like that.
Or so usually you'll hit enter maybe a couple times.
Oh, you meant like a
like a couple lines.
That's cool. Okay, cool. Is that good?
Or like, so the curly braces, we want to type inside the curly braces.
Oh, okay. I wasn't sure what you. Okay,
and so
I see what you're saying. So you want me to go like this?
Yeah.
Like, so I can
there you
make
go.
space in there. Okay.
And so now you've got your setup function, and everything that we are calling in the setup is going to go in there.
Okay, cool.
So it knows this is just setting up the program.
Okay, cool.
And so we'll put in like size, for instance, and that's going to tell it the size of the window.
Okay, so do you want to do that one first?
Sure, yeah. And so then, there you go.
That, so then size.
And then your pair of parentheses.
And should I just do 800 by 600?
Yeah, 800 by 600, and that's going to be the size of the window.
Okay.
And then each line is going to end with a semicolon.
Perfect.
So that's how that works. And then background, we'll set up our background.
Just like that?
Mm-hmm. And then the argument, so to get back to defining what an argument is going to modify or tell the computer what to do for the background.
Okay.
So if we want just a black screen, just put 0. A white would be 100. Or 250, actually. So just 0, and that's going to tell us that we just have a black background there.
Can we do, question for the size, could we do like 1920 by 1080 just so we have full screen? And,
sure.
And just, I would like to just make it slightly different from yours.
Yeah,
so
that's fine.
Just see the difference. Cool.
We can change some other stuff too.
Awesome. Excellent. So that was background, size.
And then maybe like go ahead and save just so we don't lose.
Good call. File, save. We'll save this as Duncan run through. And then I'll just say that on the desktop. Okay, cool.
Yeah, so I don't think you can have spaces in the name, but I think it fixed that for you automatically.
Oh, yeah. There you go.
And so now, go ahead and hit the play button, and you're going to see what we've written so far.
Okay, so let me...
so they may not be able to see that.
Yeah, let me open that up for them. Okay, so this is what we're currently seeing.
It's really exciting. It's a black screen.
So exciting! So. Oh, you gave it away. You gave it away. It's okay. Okay, this is it. So this is what we're currently created. Wow. Okay.
Pretty impressive.
Is there anything else I can do with this right now?
No.
Cool. All right, so that's what we've done so far.
Excellent. Black screen.
So let's go back to these ones. Okay, cool. So, all right. So what can we do to make this a little more interesting?
Yeah. So then let's go ahead and create another function. So this is gonna be outside of the setup.
Okay.
So the setup is only run once, but now since we're thinking visually, we need to draw something to the screen.
Right.
And so that's the draw function.
Okay, gotcha.
And so you can go ahead and say void draw. I hope I'm saying it right that it's a function, but I believe it is a function. Anyways, it's a built-in
Sounds
function.
like a function to me.
Okay. And so then you're gonna have your same type of setup, parentheses, and then your braces with.
How touchy is this in terms of like spaces and stuff like that? Like having spaces in between them?
It doesn't usually doesn't care about spaces.
Okay.
But it's just kind of like programmers have certain conventions to make it more readable.
Right.
So like it's just kind of like a common courtesy to do something a certain way, because if you look at somebody else's program and they, it's all written like a piece of crap and you can't tell like what it is because they didn't write stuff very well, then that's kind of where you get into problems. But the computer doesn't care at all.
Okay,
like
that's cool.
There's only one correct way to like write something.
Okay, cool. And like what? I'm just curious. What's the difference between like I know I'm like kind of getting off tangent, but colon versus semicolon? Like, are those like
Okay, so every. Well, and I can show you on the program here, but like every. So like for instance, like it doesn't care. Like you could put your background like that, and it doesn't give a crap about that.
Okay.
It's just like.
Okay, it doesn't matter. So you
it's
can put
just
the background
for human readability.
Gotcha. Okay, cool. And so like I'm just saying, like if I use, let's say, instead of a semicolon, I used just an actual colon, would that make a big difference?
Yeah, that doesn't mean anything.
Oh, colon doesn't mean anything.
I mean, like I'm sure that it means something, but I don't think it means like. It has to be a semicolon.
Okay, good to know.
Yeah.
Okay, that was my main question. Okay, cool. So we got the void draw set up. Mm-hmm. So what do we do next?
Okay, and so now we will let us draw a circle. It should be pretty simple.
Cool.
And so so I think you can just type in like circle. And it should, and then get your parentheses, and then parentheses, semicolon.
Parentheses. Oh, it's my bad.
Yeah.
So it's so is it parentheses? Wait, like closed parentheses or open?
Just the same double pair of parentheses.
Oh, okay, gotcha.
And then
that, and then semicolon.
And semicolon. Yeah. Okay. So circle doesn't exist, so it's actually ellipse.
Okay, ellipse.
So a little more technical, a little more mathy.
That's fair. The function
and then ellipse has two L's. And it's
tricky.
It is really picky about spelling. Okay.
Fair.
And so then now we're gonna give it our arguments, which is gonna be the parameters, which we can just do. Just 10, probably 10. I think if you just put a 10 in there, it'll know
like
that it's a circle.
In the parentheses?
I think it's one. So I think it's wanting all of them. So
it's saying float, 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 float.
So do 10, 10, 10, 10, and hopefully that'll
assuage.
So I believe. That. So let's go ahead and run that and see if that is anything. Okay, so
is that nothing?
We can't. Oh, there it is.
Oh, here, let's show that. Look at this beautiful thing that we've just done. Look what we've done. We've coded a tiny. We did a tiny little speck. So is this like running constantly right now? Is it generating like did it generate just one circle?
Yeah. So the draw loop is run. the draw is a loop, so it's running constantly.
Okay, cool. Yeah. So it's just creating this tiny little circle over and over and over again. That's what you're saying. Why is there like a little like kind of like speck up at the top of it? You see that?
Yeah. Well, I think we'll figure that out as we kind of change stuff up.
Okay.
So
cool. We'll go back to this. Okay, cool. So we just did that.
So now we'll kind of get into variables and what variables are and how to use variables and that kind of thing. So
sweet.
Let's go ahead and create our, let's just call it X and Y.
Create our X and Y. Okay.
So to do that,
you mean like where we're gonna start the circle by X and Y, like the coordinates for where we want to start it? Okay, cool.
Yes.
Awesome.
Okay, and so we're gonna create the variables outside of the functions, and you can write angry comments and tell me that that's not proper programming, but we'll go ahead and do that. So maybe like put a space in there and then write int X.
INT?
Mm-hmm. Or actually, yeah, just int. Okay, I'm sorry. Int space X equals, and then maybe put a space between the equals and the X.
Okay.
Width over 2.
Like that?
Uh-huh. And then I think you need parentheses around the width over 2. And then close it off with a semicolon.
Okay.
And now what that is telling the computer is that, so an int is an integer, which is like 1, 2, 3, 4, 5, 6, 7, etc.
Sure.
And then a floating point is going to be like more specific, so like pi, like 3.14159, blah, 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 blah.
Sure.
That would be a float. So it's just...
That's a non-ending number. Like a
like even like 1.00001 would be a float because it has a decimal place, basically.
Okay.
So it's just kind of a specification of like how much space this number is going to take up in the computer's memory, because a 1 doesn't take up very much space, but if you have 10 decimal points, then it's going to take up a lot more space.
Okay, gotcha.
So this is saying we want an integer value, and so it's defining the variable x, and we're setting it to width over 2, which processing knows that width is equal to the width of your screen.
Oh, okay.
Or the width of the window.
Okay, cool.
And so then let's go ahead and create another one. So everything will be the same, except it'll be int y is equal to height over 2.
Okay.
And that's going to give us our height. And now we'll use the variables, and so I believe the ellipse, how that's structured is x comma y. So replace the 10 with an x and the y, and the second 10 with a y. And so that's
cool.
So that way we're going to draw our ellipse at that position.
Okay. Are we ready to try it out?
Mm-hmm.
I'm excited. Okay, let me. I'm gonna move this over so that everyone can see right away. Okay, here's what we had before, and this is what we're about to create. I'm excited. Excited to see what this is. Here it comes.
You might have to stop. Yeah, I don't know.
Let's see.
What happens if you
maybe
stop?
Stop and start. Yeah. You see, I'm gonna close this and see what happens. Let's see. Okay, stop. Start. So it's doing. It looks to be. Yeah, doing the same thing.
Yeah, so it's let's figure out what we did wrong here.
Okay, I'll go back to. Okay, cool. So yeah, let me see. Sorry, let me pull these back up.
So maybe. Well, I guess we can sort of troubleshoot this one way. So let's just directly put width over 2 into x and height over 2 into y and see if that gives us what we're looking for.
What do you mean by that?
So copy that the whole thing with the parentheses, except that, and then copy that and put it to where X is. So this is basically what we were doing with the variable, but it wasn't showing us the results that we wanted. And then do and then do stop and then play.
Okay. Let's try this out and then
there it is.
Okay, cool. So let me move this over.
So I don't know if you'll have to create a new window every time or not.
Oops. Let's see if Oh. No, it's not finding the one I want. Let's see. I want it to capture the window. Let's see. Let's try this again. Sorry guys, I'm just trying to show this to you guys because it's for some reason it's not showing up.
Could we just put it on the desktop and then you wouldn't have to?
Yeah, I know, right? I would. It doesn't look like that's working. Let's see. Maybe if I close this one.
Yeah. I think might be finicky with like the start and the stop.
Yeah.
I don't know.
Let's see. There we go. There we go.
Sweet.
Okay. Here it is. Okay, so now we got this little circle in the middle now.
Mm-hmm.
So what happened there? Like basically, it's taking height over width.
Yeah, so it's taking the width and dividing it by 2, so that's going to be the middle of the width, and then the height dividing by 2, that's going to be the middle of the height.
So these are coordinates basically, and like what determines the size of that?
That's going to be the second 2 parameters, the 10 and the 10.
Okay. Cool. So basically going back to here, the 10. Okay, so 10 is very small, clearly. 10 pixels. It's just pixels?
Mm-hmm.
Okay, cool. So if we made it like, so this is 1080 by 1. So if we did like, let's say like 3, could we try 300?
Sure.
Okay, let's try that.
You're not gonna break your computer that way, I don't think.
No. 300 by 300. Let's try that out. Let's move this one over. Oh, cool. So now we got a circle.
Cool.
Wow.
Okay.
This is exciting. Even though it's so basic, it's exciting. I love it. Okay, cool. So, awesome. How do we make this even more epic?
Okay, so let's go ahead and create how about let's see if we can get the color
Get some colors in there.
kind of working. So,
yeah.
Okay, so kind of forgot how I did the. Oh, okay. Okay, so now create a new fill, and so that's gonna define the fill color.
Okay.
And that's gonna be in our draw function.
Cool. Shoot, I'm just realizing that it's taking. Hold on, let me grab the. Wait, this that. Oh, okay, cool. I don't know why it's not showing up as. It's showing up as like the same one is appearing twice. But anyways, I'm not gonna worry about that too much. We'll just focus on the one that I have right now. Let's see. Sorry guys, let me just. This thing's being a little bit wonky. Okay, so I don't know what the deal is with this one, but let me just get that up here. Sorry. Okay. Cool. Alright, let me just get that up there so that's not as confusing. And okay, cool. So sorry, I was a little distracted.
Yeah.
Like,
so
what were we doing
back to the sketch. So created below ellipse. We're gonna define the color of the shape, and so that's gonna be fill.
Okay, so just like this.
And then inside the arguments that we're gonna give that are let's go ahead and give it R, G, and B as variables.
Yep.
Or so it's gonna be R, comma, G, comma, B.
Okay.
And then
B like that. And like that.
And then semicolon.
Oh, sorry. Yep.
And so then we need to define. We actually need to create those variables. So below our x and y, below where we define the x and the y.
Like here? Up here, or?
Yeah, like on the next line below that.
Mm-hmm.
Then do int r int r equals 0. You don't need a parentheses. Just a 0.
Oh, I see what you're saying. Like that?
Yeah, you don't actually need the parentheses.
Oh, it's just 0 at all.
0.
Just complete 0.
And then semicolon.
Okay, cool.
And then int g, same thing.
0, and then
b.
Okay, so these would be like, would these be considered parameters for the function?
Yes. So those are variables.
Variables. That's
and we're using them as arguments.
Gotcha.
For the fill function, and so that's going to give us a black circle. So that's not very interesting. So, let's go ahead and say in our draw function, we're going to say r plus 1 or r equals r plus 1.
So just like at the bottom, like right here,
r
equals r plus 1, like that. Okay.
And then close it off with the semicolon.
Okay.
And now let's run that and see what that looks like.
Okay. Play that.
There we go.
I want to see it. Let's see. Let's try it again. Dang it. Okay. Let's see.
But it only happens once.
I know, right?
So.
Let's see if I can get that up there. Yeah, that's not happening. Window capture 2. Here it is. Okay.
So we just created the inverse Japanese flag with our programming skills.
Let's see, if I close this, no. Okay, cool. We get the idea. We got that. Okay.
Yeah, so we can put in so if we go back to our program, let's put in a little way that we can restart it.
Okay, cool.
And so,
how would we do that?
Yeah.
Sorry, go ahead.
So we're going to create a new... So now we need some kind of input from the player.
Okay.
So, let me just see this. So, for instance, say we're using a keyboard input. So we're going to create another function, I guess. I hope I'm using that right. I think I am. Another function, we're going to call it void key pressed. But yeah, so we're still in our draw function, so we need to get out of our draw function.
Oh, like literally like beyond this bracket?
Yes.
Okay. Oops. So void
key pressed, and then pressed is going to have a capital P, because that's just like a convention in programming that you do that. And then you're going to need parentheses, and then you're going to need curly braces to show what's going on. Is it a function or is it a structure? I don't know.
Maybe there'll be some programmers
just write angry comments and I'll remember better next time.
Yeah.
Okay, so now we're looking for input from the keyboard. So now we're gonna. This is our first sort of our first real programming thing. Is like your logic is like if then statements. So if this happens, then do this.
Okay.
So if, and then parentheses, and then the curly braces like we've been doing.
If this, and then
correct, yeah, and then
that.
Yeah, and so let's just so that looks right, and so you can see the if then structure, right? So
yeah,
if what happens in the parentheses is true, then what happens in the curly braces happens.
Okay.
So that's how if then works. So we're gonna say if key, so key, just key equal, and so this is a logic thing, equals, and then we'll do just a single apostrophe, or like space apostrophe.
Why am I not thinking of apostrophe?
It's like a quotation mark, but there's just one of them.
Oh, okay.
Like apostrophe S. But then we want a space in
the
apostrophe.
Yeah, my bad. Okay, cool. I totally forgot what the apostrophe is. Okay. apostrophe S, and
or
then,
like,
is
yeah,
that right?
So
Right.
2 apostrophes.
So apostrophe S, like that.
Or no, we don't need the S. We just need the apostrophes.
Cool.
But we want a space in between the apostrophes.
Gotcha.
And so what that
Okay.
is telling us is that so the key that we're assigning to that is the space bar. So if you hit the space bar,
okay.
then do this.
Okay, so what did equal mean? Why would
So,
two equals?
So there's a difference in logic between equal and equal, and that's just kind of like if it's yeah, I'd have to refresh my logic, I think, but it's like I think it's evaluating a Boolean. So so there's different types of data. You have numbers. Like we talked about the integers, right?
Right.
And we talked about the floats. So an integer is 1, 2, 3, 4, etc. The floating is going to have a dot, and it's going to have numbers after the dot.
Okay.
So it could store a lot more values that way.
Gotcha.
And then a Boolean is logic, so that's true or false.
Okay, gotcha.
And so I think typically equals is used to assign something. So if you say x equals 1, then you're setting 1. Yeah, you're saying that x is 1.
Mm-hmm.
But if you use equal, then it's a logical operator, and it's saying it's doing logical operation on a Boolean. I believe it's saying is the statement x equals 1 true?
Gotcha.
And so it's just a slight difference, and I kind of. I would say how I explained it is about 80% correct. If I had a textbook in front of me, I could say
that's
it
fair.
better. But
yeah,
that's all we really need to know at this point.
That's great off the cuff. Anyways, like we just decided to do this today, so this is perfect.
Right. Yeah. There's been very little preparation for this project.
Yeah. Perfect.
But anyways.
So basically, all right, we got this all set up.
Yeah.
And
So the issue. So what we wanted to kind of to say is we want a way to restart our program so we can see it from the beginning. So to do that, all we have to do is call the setup.
Call the setup?
Mm-hmm.
Okay,
so
cool.
Just write setup, and then parentheses, semicolon.
So basically,
so
right
that's
now,
saying go back to the beginning, go back to
they're like,
the book of Genesis.
If the key spacebar is true, then the setup will restart. Mm-hmm. Is that what you're saying? Okay, cool. Yeah. So we can run this right now?
Mm-hmm.
Okay, that's cool. So I'm going to click run. It's going to there. And then I'm going to put this on the screen for you guys. And, okay, so there's the red thing. And what should happen if I push the space bar, oh, it does. I mean, technically that is. Mm-hmm. But it's like very fast. It's much faster than it was created.
I think... Well, we don't need to worry about
something's
this too
happening
much,
either way. So, yeah.
I think we've got the basics down.
Yeah, that's cool. Okay.
Is
there so like we have about
15
minutes? What do you think?
Okay, we got 15 minutes.
15 minutes. How can we? What would be like the best? Oh, go ahead. You were gonna say something.
I mean, it's not that important, but we could put I think if we put our variables in the setup.
Oh, okay.
Then, but then they wouldn't get down to the. Okay.
Can we make a delay in the setup process? Or that would just be more difficult.
So I think what we want to do is so see here. If you're thinking of like, I mean, is this too detailed or like are we trying to like wrap it up in 15 minutes?
Yeah, probably wrap it up in 15 minutes.
Okay.
Because like we could.
Maybe there'll just be a part 2 to this. Cause
yeah.
This is kind of like a big project, I guess, to learn computer programming in an hour. But
I think this is a good so basically, what are the main points that we went over so far? Like I guess like this is. I don't know. I guess like, do you feel like it's a good point to wrap up since there's only like 15 minutes left?
Yeah. Let's just try and fix our what we've done wrong so far.
Okay.
Just
cool.
So that like people can kind of get a better understanding. But basically, what I was trying to explain is that whatever, and they can see what I'm pointing to, right?
Yeah.
So whatever. So like this is like its own little universe here.
Yeah.
This is its own little universe here.
Their own little voids.
Right.
Of space,
in the beginning there was
continuum.
In the beginning there was nothing.
And then there was draw.
So, but yeah, and so
So wait, so is God technically void space draw?
Yes, I believe
Cool.
so.
Hell yeah. And then what is void space key pressed? Who's that?
That's Satan.
Shit. Okay.
So basically, just the point I was trying to make was that what happens in each one is not visible to the other one unless you specify that it is.
Okay.
So I'm just going to try and fix this real quick, just so that we're not
Do your thing.
just so we're not propagating errors here. But so like right now, when it's running the setup, these variables are not getting reset
Why is that?
because these variables aren't in the setup.
Oh, okay, gotcha.
So setup only knows setup, draw only knows draw,
So
etc.
would we just have to move this bar, like that bar that I'm pointing at? What do they call that? The bottom bracket or that the last bracket there?
braces.
The braces, yeah. Would we have to just move that brace below the int b to include it in the setup?
Yes, we could, but the only problem with that is then draw wouldn't be able to see our variables.
Oh,
You see?
interesting.
This is the life of a computer programmer.
So basically,
You
you're
have to think
saying
about
this.
this crap
You
all
said this
day.
was like this was like incorrect or like crappy programming because basically it's like kind of like throwing it in a middle space where like these other void programs can grab from, but like it's not clear where it could like cause a lot of issues in the future.
Yes.
Okay. Cool.
That's correct. But just for this example, this is really simple. So how we're going to fix this is we're going to declare the variables outside, and then I think it'll make more sense. Oops. That's supposed to be G.
Oh, it says int r twice on that one too. Sweet. So that'd be G. Yeah.
Okay.
Cool.
So now we're going to declare the variable outside of the setup so that it's visible to everybody. But we're going to actually set the value of the variable.
What does int mean again? Int.
Um,
What does that mean again?
Integer.
So you're like integer R is a thing, integer G is a thing, integer
Yes.
B it's like Pokemon Go, integer R
Exactly.
go.
Exactly.
Okay.
But we declared it out here, so all of the other little islands can see it. But we actually set the value in the setup, so that when we run our setup, it'll reset the variables like we wanted.
Okay.
See?
Oh, it works. Hold on, let's show this so they
Yeah.
can see it. This is amazing. All right, so here's a red dot, and watch this. Oh, look at how beautiful that is. Just comes into, wow, it just appears. So that's kind of cool. The concept of like basically fading in is really like this process of like repeating values over time. You know what I'm saying? Like this circle, it's not just fading in; it's actually just repeating the values over and over again. Is that true?
Well, so
how is it forming?
Okay, so if you go to our code.
Yeah, let's go back to the code.
So color is a value from 0 to 250.
Right.
So if we go down here, we said R is equal to R plus 1. So R starts out as 0, and then each time the loop runs, we're adding 1 to R.
Okay.
So the value of R is increasing.
So basically we're going from black to progressively red.
Mm-hmm.
And, and we're only going directly towards red. So it's like a different, we're increasing the power of red, essentially.
Mm-hmm.
Or the brightness of red.
So like the brightest red would be 250.
Okay, so we're basically, R plus 1 is a brightness. That is the property of brightness, specifically.
Yeah, it's the R value.
So like
the intensity of the color.
Okay, gotcha. And the intensity.
So all colors in the RGB world, all color can be represented as values of R, red, green, and blue mixed together.
Gotcha. Right.
So right now we're only changing the red parameter.
Totally. Gotcha. Okay. Cool. And it, like, if basically, like, can you change the hue, or like different factors like that using this program, or have you?
Yeah, it's certainly possible. I mean, it's a little more advanced, but
Gotcha.
Yeah, I don't really know what hue is actually, but
So one of my questions that's coming up. Let me move this back. One of my questions that is coming up right now is like, what if like the program already knows like red, green, blue. You know, but what if it doesn't? What if there's a color that you want to implement that it doesn't know? Do you at that point define what that?
But like all colors
is? Stem from RGB, right?
Well, yeah, I mean, like in the RGB, like yellow,
right,
would be a mixture of. Well, I don't know how.
Right.
I can't really think of it off the top of my head, but it would be a mixture of like. It's just kind of how computers code things.
So basically, yeah. So that's a better, easier example where it's like, okay, so like, you know, this color plus this color equals this color, and that's and then we would define that as like, if it was yellow, Y, we'd say Y equals blah blah plus blah or something like that. But what if you want it? What if it's something like more abstract, like hue, you know, or contrast, you know, like. I think that's more of.
I mean, how do you define hue?
I don't know. I should probably know
if you can't define it, then
you can't, and the computer can't. Yeah,
so.
No, exactly. Okay, so basically, it's like you have to be able to find something. I guess
right.
Like
that's kind of the whole thing with computer programming is you have to know logically exactly how to specify it so that the computer can understand.
That's interesting. So you have to have such an accurate understanding of what that is for it to create something. So basically, like, in order to create
there's no half-assing a computer program.
Yeah.
It's all or nothing.
So like, bring this like to like a spiritual place, like God. If we were like programmed, if we were a programmed thing, like someone would have to know like the ins and out of us, and like a program like so intimately. That's kind of crazy.
You mean like DNA?
I guess you say DNA, like our DNA, or like, I don't know, even like the dynamics of nature kind of a thing.
Well, yeah, I mean, I think that certainly some mathematicians and probably people think that like the world is made of language. I know Terence McKenna said that a lot.
Totally.
And so
basically,
if you know the programming language of reality, you can change reality, I guess.
Yeah, that's crazy. That's a crazy thought. I mean, this is a super basic, simple program, but ultimately it's a program that could be used to create life in a sense. Would you agree? Or like, I mean, like that's like a whole different level of scale, obviously, but or is that?
Yeah, I mean, actually, one of my professors in college created this kind of like life simulation sort of a thing that got kind of famous, but so he probably has thought about that question a lot more than I have.
Right.
But I think like I mean it could be, yeah, I don't know if you would say it could really be alive. I mean, maybe at some point in the future things will get that advanced, but
sure.
It certainly would not be alive in the way that we think of living things. Right,
sure. This is very like,
but
yeah, I get what you're saying.
I mean, I guess you're kind of asking about like artificial intelligence, maybe.
Yeah, I guess so. That is like, this is like more like a visual form of that. But anyways, I don't know. I just like brought up like that.
Yeah,
thought.
No, it's interesting.
Like that place,
the implications of what you're doing.
Yeah, no, definitely. Well, anyways, thanks so much for like showing this. I personally have really wanted to have like I've never been introduced to processing before, and like I think I'm definitely gonna like play around with that. I think your program is very fascinating, and I want to learn more about it. So, anyways, thanks for showing us that.
Yeah,
and
sure.
I think that's all we got for today. So thanks guys if you ended up watching this. Thanks guys for showing up, and we'll probably do, if you guys like these sort of like instructional or like I guess like hands-on sorts of videos or live streams, like let us know, and because I'm sure we'll be doing more of this kind of stuff in the future. So do you know any other forms of programming, by the way, before we end? Like, or is it more processing?
Yeah, so processing, is really pretty much the same as like Java.
Okay.
But
cool.
they've it's more geared towards like visual art. So.
Oh, cool.
But like if you know processing, then you can pick up Java pretty easily, and then if you know Java, like for instance, Unity, the program that is like a 3D game engine, but it uses C#, and I'd never done any C#, but just with my knowledge of what I'd done before, could pick it up pretty quickly. So.
Oh, that's cool. Yeah. Okay, so it's kind of like a cross-platform,
mm-hmm.
or like similar principles that other programs use, basically.
Yeah, I think probably most object-oriented programming languages are going to be similar.
Okay, awesome.
Yeah.
Cool, man. Well, appreciate it. We're going to go play some ping pong. The obvious next choice. But thanks you guys so much for watching, and I will talk to y'all Monday. All right. Peace and love, my friends.